Hello everyone, and welcome to Evolving a Clean Pragmatic Architecture. I should start by correcting the title, right? Person. Honestly, one of the folks that know clean code best is my pair back home, Bianca, who is, of course, a woman. So, okay. I will start with the same stuff that I started yesterday. I promise the third time I won't put this, but still, since there might be of you some that didn't attend it yesterday, I want to repeat these questions. When something annoys you very much and you cannot avoid doing, what do? Of course, you leave it for tomorrow. No? And then you become a boss and then you delegate to the other team member. Of course, that's not a very mature way of doing stuff. As you said yourselves yesterday, the way to do this is to do it more often. It won't hurt you anymore. This is the fundamental principle behind the extreme programming movement, which very simply say, if you are on your own branch for the past 2 months, it will hurt you. So what do they say? The continuous integration, frequent synchronization with the if you can do trunk development, trunk-based development, go ahead. If not, at least synchronize daily, not weekly, daily, because the long-lived branch inhibits refactoring. It will freeze the code. Then, when you do merge, finally, they call you for a code review. And this is a reason to be humble, right? You go for the code review. What do they say? Don't wait the code review. Ask you help when the problem is just above your head, 1% above your head. Go ahead and ask for help. Step on your pride and ask for help. Then don't wait for the refactoring sprint, like we saw yesterday. Instead, do continuous refactoring. Everything you push on Git should be worthy of being added to your CV. This is how I write code, right? Sample code. Don't limit on just implementing your simple stuff. And the fourth fear is the most terrifying of all. When you are running some code with exactly 0 unit tests, what do they say? Don't postpone writing those tests. Write them beforehand, if possible. If not, whenever you push something, push them together with your tests. You are all agile, of course. And agile means that business can, chase us with late change requests, all, of course, with a fixed deadline. And I should say that again, because this will remain recorded, and I want you to be there. Deadline, the first meaning in Webster Merriam is the line that if you cross in the prison, they can shoot you without warning. Okay? Okay, so software craftsmanship is there to resuscitate those technical practices which in time got lost. Okay, my name is Victor Rentea. I'm one of the 2 Java champions in Romania. I'm a lead architect at IBM. But basically what I love doing most is this software craftsmanship, and you can read this Bucharest software craftsmanship community. I founded this community exactly to promote, again, these values, the joy of writing code in the essence, right? Pair programming, refactoring, TDD. Nice. Then I've been talking quite a lot already. I have even a playlist on YouTube. The point of this slide, as you know, is that I have a website, of course. Over the past 6 years, I've trained quite a bunch of developers already. That's quite a lot of speaking. So, Spring, Hibernate, Java 8, design patterns, architecture, clean code, unit testing, lots of stuff, performance, Scala. I even teach on O'Reilly learning platform. I regularly do these design patterns there. Lots of training. And yesterday we covered this part. Today we will cover a part of this. And later today, after lunch, we will cover this part, actually. The most demanded trainings in my, but of course, you may not be interested more than the fact that I post regularly on these 3 social networks, stuff that I read, that I learn, funny things, interesting things, motivational things. I initially started posting stuff to answer the question how to convince my boss to give me time for refactoring. That was the initial, I wanted to help people get time for that. Let's start, come on. So, what is the most important principle in programming? In 3 letters. Come on. Take a chance. Any ideas? SRP. SRP means not to pile stuff together in one single class. Long class. No, don't do that. But instead break it up into small pieces. Each focus on doing just one single thing. Highly cohesive design. Don't just put stuff together. Have the courage and guts and nerve to take them out. Hand in hand with this highly cohesion comes coupling, which means that you shouldn't have the system as you do today, but you should break it up into pieces, each with less dependencies between your classes. Not only it is easier to understand, but it is also famously easier to test a code which is loosely coupled. And we will see after lunch what I mean by that. So basically, coupling means to reduce the dependencies between your components. Quick note here, since you are on the up level of audiences, Facade will be famously doing will have lots of dependencies. What I really mean is that a method in the class should not be a method, or a feature in the class doesn't depend on more than 3 or 4 other classes. Per method coupling, not per class. It's a tricky stuff. So, you want loose coupled. And the third one, the famous one, don't repeat yourself. You see code and you see another code which looks very similar, and you play that game from kindergarten, find the differences. Huh? After you suffer like this for several years, you embrace this pattern. Don't ever copy-paste your own code. You are allowed to copy from those smarter than you, but don't spread your code over and over along with all the bugs. Right? And my personal principle is actually keep it simple. From the original, keep it simple, stupid, from the US Navy. The thing is, premature encapsulation, over-engineering is the root of all evil, basically. If you are overdoing stuff up front, like Dimitri said from Bulgarian Jug, premature refactoring. It's an interesting concept. Too much factoring, too much design, basically. It's also a possibility. And always protect the developers, embrace them, defend them. Do little bits of invisible magic to reduce their effort and risk. Little thing that you can help them to get along the common pitfalls. Right? But when I say that, I don't mean you should invent a framework that all of them should follow. That stinks of pride, right? It's my framework. This is sometimes called CV-driven development. It's my framework. Don't do that. Don't do that. Avoid doing that. I have this idea. Once you've put the third time something in production and it worked for several months, then you extract into a common library. Don't just start off with building a framework for 1 year. Extract from what worked in production. And also, how many masterpieces, the art masterpieces were created during world wars? Very few. Why? Because people were just terrified of what might happen to them. So fear kills creativity. Meaning, we invest a lot of time and money, actually, in building safety in your tests. Tell me, so honestly speaking, is this how it feels when you build software? The word build in Maven, the word build that was there from Makefiles, I don't know, decades ago, is completely wrong. This is not how we build software. We don't lay layer of concrete after layer of concrete. Instead, this is how we write code. This is your code. This is actually your code base. Your code is a garden, it's organic, it needs continuous care, right? You need to look after your code. And you know perfectly well what I mean. When a code grows in an unexpected direction, you must always be willing to cut and to chop and to arrange nice the living thing that grew. There's actually a full movement in this sense. They call themselves software gardeners. Very interesting. So it's a living thing. So basically, if in your garden something grew very much, there won't be any moment easier than today to stop it, right? Imagine some disease that spreads in your garden. You need to stop it today. So don't postpone it. If you postpone it, it will become harder and harder to fix it. And also what I've seen in many projects, people, those of you who can foresee the future, raise your hand. Good. We need to talk afterwards. So, the point is, how could you know what features will become super complex in time? At first, they are super easy, super trivial, but in time, they grow and grow and grow. So our goal for this talk will be to try to see a way in which we can build an infrastructure, a software design which can grow to match the complexity that is being added, right? And at all moments, keep your design simple. Can you imagine a fight between a Teutonic knight and a ninja? Just imagine these two fighting. Who do you think will win? Will the design pattern form win? Will the over-engineered code win? Or will the simple, supple, elegant, elastic code win? Which one do you prefer to be? Do you want to be armed with a lot of indirections, with a lot of tactical patterns? So, or do you want to keep your code simple, supple, always willing to bend from whatever direction comes the menace, the change request? But the whole point of this talk is to see a way to build an architecture that evolves to match the growing complexity, right? The second rule of thermodynamics, I may be wrong, but has something to do with entropy, which is proven to be continuously growing. How to fight that in our system? Okay, let's start with the basics. Entities are those things that keep your persistent data. But the point about entities is that they are under your direct control. You should take advantage of that opportunity to simplify the implementation of your business logic. What I mean is to sprinkle, is to spread, is to put a lot of little bits of business logic in your domain entities, like get full name. Guess what it does? Then activate. Look at that. If the status is not right, it will fail. This is a state machine. Then it also sets the date and maybe some activation user. So basically this can encapsulate a bit of a state machine, right? And you don't need the setter for the status anymore, nor for the activated by. You can encapsulate that through encapsulation. Then is active or can place order, little bits of predicates basically, which are there. Why? For the use of Java 8, of course. Right? It's so easy to do. So this is how you can. Even more, if you are still on JPA, those bidirectional, the relationship you need to take care to set both sides. You can cover this concern right inside your entities. Okay, but there is a catch here. Don't overdo it. Right? I don't want you to have bloated entities that contain such code. Imagine that. Can you see this token here? This is a semicolon, my friends. You should never have a semicolon or a percentage D in your entity. This is the V from MVC, have nothing to do with your entities. So the point is, keep your entities focused on the business logic, not on any other concerns. Nice. Now, value object is the other thing that you have in your domain model, which is basically a grouping of domain data. We did that yesterday, if you paid attention. The full name and the address classes were exactly that. And then these value objects have a certain features, one of which they are supposed to be small and immutable. Immutable meaning this. If you do that, you gain comfort that once you create it, you can check that that they are created valid by doing this here. Once they are created valid, they will move around being valid, can never be corrupted. Now, of course, the difference between a value object and an entity is that an entity has a persistent ID, read PK, right? While a value object doesn't. When you compare two value objects, you will always compare them by field by field. If the currency is the same and the amount is the same, then the money instances are equal. Whereas comparing two customers with the same ID, even if they are dramatically different, they will refer to the same customer. Changed, yes, but it's the same customer. Quick note here, if you are on any ORM out there, don't ever implement hash code equals. Okay, that's a point from Vlad Mihaj. Don't ever implement hash code equals. I did it, and I have some scars on my back because of that. If you are in this world, you will put here embeddable at the top, and you're solved, right? Good. So then you have this domain model very fine, you are very proud of it, and you expose it to your user interface. What will then happen? Well, the user interface has different goals. Look, they want data structure to represent a row in this table. Just imagine, this result set takes data from the customer entity, from the order, from the region, and so on. And basically, it's an arbitrary aggregation of data, right? There is no matching entity or value. I mean, you will force it to be. It's just an arbitrary projection for the use of your representation, basically. Or can you imagine the can be deleted field? Just imagine that. Can be deleted. True, false. Why would UI ask you for such a field? Think, why? Easy. Do you want to display or not? The button, right? Don't ever have such a field in your entities. There's something which is, what the heck, right? So UI has different goals. That's why you should not expose them, your entities, unless your application doesn't have a brain. There are such applications. But basically, what you want to do is to give them data transfer objects, which are a completely separate set of data structures of different kinds. Those that we just saw just now are what's, I don't recall who said this first, but they refer to light CQRS. Now, light CQRS, read-write model, this is a read model, select, that's a view in maybe, right? Maybe even a materialized view, whatever. But basically, it's a sort of, get it? Light CQRS. Just an arbitrary select from the database. And you have this DTO, and you've done OOP, right? My point is here, is since this object only is serialized as JSON probably, I want it to be as dumb as possible. And guess what? I will destroy the getters and setters. Oh my God, what are you doing? But just look for a second how nice this looks. This brings up memories, right? So then, it looks, well, I know what you're thinking. Beep, beep, beep. It goes like this, right? You can tune it, right? All right. Good. Organizing logic. How do you do it, really? So, first of all, I wanted to ask you, what is this symbol from UML? Yes, I've put the logo of UML. Yes, it's there. You see it right. It's UML, correct? What does this symbol mean in UML? Interface, or in extenso, endpoint. There you go. There's your endpoint of your controller, right? Which you hope they will work fine to your HTTP. Good. Then, probably most applications have a service layer, right? In which you put your domain logic. But what I saw in my teams that I go for, that's what the common scenario. Now, a quick note, service can be missing if you do have all the logic in your PLSQL. Then there is a repository, of course, which talks to the database, and there is an infrastructure which talks to other services. Then the point of this layered architecture is the calls only go down, right? Now, the entities reign in your service layer. That's their kingdom. The DTOs of JSON, whatever, are there in the controller layer, basically, because they are exposed. They are the data structures backing your API. Now, there are data structures coming from outside, right? We will talk about them in a second. But there are some projects also choose to decouple those entities from the persistence layer completely. And they choose to do get, set. You know what I mean? Get, set. Just imagine a third model of data that is used only by the repository. What would you do here? Here. Get set, get set, get set, get set. And then they apply for another job. Okay, very few of you laughed, so we don't do that much. Very, very good. There are a few percentage of applications that really need and take advantage of this. However, you will notice with time, after 1 year, after, let's say, that the first thin layer of the services is special. The first thin layer of your service does things. Now, one question is, where do you do the mapping? Some teams choose to do it in the controller, but then you might find out that the mapping is 30% of your logic. And then, there you go, in your controller, there's a bloated controller. Why? Because the mapping concern is very complex. Okay, there is also the validation concern. Some people struggle with annotations, others choose ifs, whatever. The question again is, where do you do them? And there is also, if you are on relational, where do you open and close transactions? Now, opening and closing them in controller, it's wrong, honestly. So they will do these things. Many teams choose to do these things in the first layer of service, which basically makes them different than the rest of the services. Only this thin first layer handles that. And this is how, my friends, the facades gets born. When you take that layer and put it a name. Some people refer to it as an application service. But again, we have two places now in which to put the domain logic, here and here. Where would you put it? One more thing. A facade normally has one method per each method in the controller. So when it is called, it turns back and calls the other method in the services, like an orchestrator. Right? That's it. A facade is basically an orchestrator. That's from the Gang of Four pattern, really. But then, you have to do conversion. Where do you do conversion? Well, this is the kind of code that you would write, and I am sure nobody of you has got into this field to write such code. I hope. I mean, no. This annoys us, so we want to hide it out. Where one place you could put it in the constructor of the DTO, which is fine, because the DTO can depend on the holy entity, not the other way around, right? Now, if the conversion is too complex, you might end up extracting some transformers. That's the best name I've ever heard of. Transformers. But then, this is the first time you saw extract when it grows. You will see it 2 or 3 times more. What do you feel now? Validation. Emotions. What do you feel? This is what many teams feel. I spent days, full days, 8 hours discussing with some teams just about validation, for Christ's sake. Just very quick run over them. There can be external and internal validation. External rely on other queries. There can be ubiquitous validations or status specific. Think state machine. There is this, this draft state in which the customer can have a null name. Rings any bell? Okay. That's basically use case specific. And you will end up struggling with validation groups if you are on annotations. If you choose annotations or programmatically, or if you mix them both. That's a pleasure. Where is that validation? In the if or in the annotation? So that's the pains that you experience. Then, where do you put those annotations? Or what do you validate? Do you validate the DTO? Do you validate the entity? Do you validate both? I've seen people doing that. My God, how much work they spent there. If you are curious of any of this afterwards, just hunt me down. And there you go, you have logic. And they are pooling features. Where do you write your logic? Now, ideally, you should stick as much logic as possible in your entities. And this is, recognize the book? I won't show you entirely. But then things that you can't put in your entities, you will end up putting in some services, of course. But now you have another option in the facades. How do you choose? Where do you put them? And that's a cryptic, that's a horror question, even for domain-driven practitioners. How do you decide what your domain is, and how do you decide what's applications service? It's a thin line there, which many teams don't know how to handle. This is why, partially, I came with another approach. Not me, but composed another approach. The facade, I will write all the logic in the facade up front. Everything there, pile up together, and let it grow. Now, whenever a use case grows too much, I will extract the domain service. But my friends, look up the colors. Can you see the colors? This is yellow, the color of joy. This is something of reddish, an evil color. Okay, good. Bear in mind this. So to hide complexity, then if the 2 domain services or 2 facades do the same stuff, I will extract a common class and use it from both sides, obviously, to not repeat myself. Fair enough. But let's talk about the colors a bit. Domain services are the same color as your entities, the color of joy. The trick is that the DTOs that you receive from your user interface are fragile. There is a say, I'm not sure if it's in all languages, but your client is your master. Right? Meaning that the DTOs that you don't control are like sand. You won't build lots of logic on structures you don't control. That's why I don't tolerate not even getters and setters. If you would put the first method in the DTO, you will feel awkward. That's what I want you to feel. So the point is, I want to keep my DTOs out of my logic. I don't want to be writing logic on my DTOs. So the first thing I'll do, I'll convert them. Recap. What does a facade do? A facade, folks, this is very intense. Watch it again afterwards 2 or 3 times. This is facade. What does a facade do? The facade is the first thing that sees the DTO, so it converts to the entities. Good. Now, if this conversion is complex, I extract it away. The facades, I will start building an entire use case there. If the use case has 3 lines, I'm fine letting it in the facade. If it grows too big, it deserves a home. Then the facade is also concerned, the presumption of guiltiness. Everything that comes from your user must be assumed as whacked up. That's where the validation happens in the first time you see a structure. Good. Now, I will impose one more rule. The rule is that, let's try if I can zoom, yeah. The facades are not allowed to call each other. It's very important, because if you do that, how many of you are on Spring? Achoo, Spring. Good. No, half. Listen. Then, if you do that, you can weave aspects in front of your facade, to start. In short, each transaction requires new, or your custom aspects, like I do, to log stuff. Exception handling and access control, I will do earlier, the famous REST controller device. But the point is, all of these start from the facade, basically. This is where you start building and you extract away. Now, let's see this principle in more detail. What the heck is that, really? It means that when a class grows too big, imagine, 200 lines. Does anyone laugh now? 200 lines, okay. No, really, my classes are this length, 200, 300. After 300, the build fails. Simple. Then, how the heck, right? So this thing that you create grew, and at some point you think, what the heck, who are you? I don't recognize you. You were so kind, and what's wrong, so small, yes, so innocent, you were named, but I mistakenly named you order service. And other people came and stuffed logic in. Look, order service, poof. Moral of the point, the name you choose to be as humble and as specific as possible. Why? If it were named place composite order service, no one would ever put anything else but that feature, So don't name overly generic classes. That's a trick there. But now you should look for a name, basically, that will summarize a set of methods in that class that grew. It grew up as a big fellow, as a teenager. So then what do? You extract. If you find a good name, you make a new class. That's it. Piece of cake, right? You know that quote? There are only two things hard in programming. Cache invalidation. And naming things. Yeah, naming things. Because it's so hard, because it has to do, it was so innocent. I created it myself, with my hand. And now look what a big fellow. So basically you are sniffing around that class to see if somehow it started doing more than one thing. And you crack it. That's why CRP is so complex, because you have to figure out when a class started doing more things. That's the flavor of SRP that I love most. The flavor that you apply when the garbage piled up. I don't want you to be applying SRP. You start the project. You stay like that. Yes, we need these 200 classes to do that, each of 10 lines. You see? I don't want that. I don't want tiny classes, because otherwise I will be ending up scrolling in the package. Know the feeling? Open the package. Don't do that. So, I like the SRP that you apply when the things piled up. Well, maybe not that much, but like that. At which point you start sniffing and you start extracting. It's quick, simple, trivial example. Customer facade, if it starts doing save customer, get customer, search, and then suddenly save customer preferences, get customer preferences, stuff that has to do with the preferences of the customer. And then what can you do? If and only if the class grew too big, this time and I break it in two. But the point is, pay attention, I will do something weird with my hand. From one class, I extracted another class as a sibling of the first one. This is horizontal splitting, my friends. Horizontal. What the heck is that? Horizontal. Whoa. It means that that thing that called the former class now calls the sibling. You feel it? Are on the same level of abstraction. Folks, abstraction can't be, in English, it's not even correct to say it's more abstract than something. It's not correct. But this is on the same level of abstraction, meaning they are on the same level of detail. Well, wait a second. If there is horizontal, could it be vertical too? Let's see that. Vertical extraction is when you have a class that requires some logic and then another class wants the same stuff. I hope you won't do copy, but you will extract nicely to a separate class down, extract down vertically, and use that other class for reuse. But also I wanted to imagine a case in which the order service has a specific use case, super complex. Just one single particular kind of order is super complex. Then feel free to extract that one in a separate class to keep things simple. So basically, I wanted to continuously extract down when things grow up. This is on a, you notice this one is on a lower level of abstraction, does something very low level, fires, IO exception, boring stuff. Whereas this, handles the, I don't know, important stuff. Okay, this is hard. I won't say it's easy. It takes lots of practice. Coding katas, hackathons, mobilify, but most of all, pair programming. The reasons that I love and do pair programming all the time that I get to write code. Fun, of course. You alone. You with someone else. Come on, pam, pam. Then better design. So basically, you are digging. Well, your pair sits like that and says, wait a second, stop, Victor, says Bianca. Go there, I know, I heard, I think there is this logic already there, right? Or wait, what are you doing? This is not a responsibility. The second one is able to focus on the broader picture. Less bugs, proven, 15% less bugs. More passion, natural knowledge flow. If I call you up to teach you something, would you come? If I ask you to help me, I can deliver you some keystrokes, some shortcuts, some hints, I can inherently teach you without you even knowing that. Increases code chance reuse, obviously. Puts your pride to work. I type 3 times faster when someone is watching. 3 freaking times faster. Don't imagine I write that code that fast any time. Bonding, what building if you stay next to each other 6 hours, 4 hours per day? Easier. What code reviews? If someone has a problem, just bear with me. That's it. Okay. In a large team, I know, or remote team, of course, you have to have code reviews, but are a lot easier anyway. And faster and cheaper on the medium. Your boss will love that. You can forward him to this link. Apparently, they kind of prove that 15% less bugs, but 15% more time. Go there. Good. So, uncomfortable developer. And what does a comfortable developer feel when it encounters such a t-shirt? Have you read the message? Yes. Good. Now, tell me, what's wrong with this t-shirt? Yellow. What else? Come on, think. Come on. There is a typo. But folks, you are 700 people here. There is a typo. Yes, there's a typo. But why didn't the rest of you perhaps notice it? Because your mind closed when they understood the message. This is an antisocial message. This is a way to cut the bridges, to burn the bridges. This is an unproductive, evil attitude. Do you know what this is, by the way? This one. An ivory tower. Now, when you see such a guy, you need to go to the first gas station and enlighten him. This is light, my friends, light, right? Light. Venkat mentioned something, but not that brutal. I'm a bit more. I hope no one gets offended here. Well, I'm only against the junior architect with background of junior JavaScript developer who didn't write code for the last 10 years. That's the guy that burns here, without a head. Okay? An architect should write code continuously. Every week at least. In this happy tone, let's talk about the onion, the most advanced architecture in the world. Whew. So you have to protect some code, right? You have some code which you love. Where do you put it? You put it in the domain module. You put there the domain service, the domain logic, that precious thing that makes your application unique. versus the competitors, let's say. You put there the holy entities, or the value objects and so on. But then at some point, imagine, there is a user also, right? So in front of the user, you dig a trench. And there you go, you defend from the user. You defend from the user. But what if, now, if the direction of the dependency is like this? Any DTO from here is not able to enter. If you follow carefully, you can't possibly see from your domain anything from outside, which is good. The evil DTO is kept out of your domain. But what if, at some point in your domain, you want to call something external? If you call something external, inherently you will have to see the data structures of that thing, which is evil. So there you go, the enemy got in your fortress. You lose. What can you do? Well, you're allowed to keep it out in a separate module named infrastructure. Excellent. Now, the point is that you don't want to know about the details of that implementation, so we'll put a holy adapter in front of it. That will manage the conversion, the validation, the adapter from the gang of 4, the old adapter. And you will consume that through the adapter. Make sense? Yeah, good. Now, if this happens, the dependency between the two modules is like this, agree? Because the domain has to see the adapter. So it has to import, to depend on that, right? At which moment, whatever is in the DTO there can slip in your domain, which is not good. You want to keep the dirt out. So then what do? You peel the class. What do you get if you peel a class? An interface, obviously. An interface named very wisely iAdapter. iRobot. iAdapter basically is implemented by the adapter, but guess what? If you do that, just let's spend several seconds looking at how joyful this arrow is. Do you see it? Do you feel the joy? But let's roll back a bit time. Let's turn the time back. Whoa. Yeah. Whoa. Why? Because the adapter has to implement the interface, of course. So basically, adapter will implement the interface in the other module. Now, people ask, where is the leave? The leave? It's there in the infrastructure, because Spring knows everything, by definition. So it will know how to match, to give you the implementation of that interface anyway. So, to put it in words, whenever you want to call outside from your domain logic, you first express your need in an interface, expressed in the sweet language of your domain. It has a crown, right? And then you let the infrastructure implement the holy contract. That's the point. Just to be clear, you are writing the interface, you are washing the dishes in the infrastructure. It's you, both ways, in both places. You don't delegate to anyone. It's you, right? You put your shirt, your gloves, and you start doing ugly stuff. No? But you have to do a mindset separation. Now, at runtime, the domain is able to call the adapter without depending on it. To put it in a nicer picture, higher level module doesn't depend code dependency to the lower level module while still being able to call the lower level module. Right? Folks, those of you who saw that, is obvious. Those of you who didn't saw that, it will take you several days to get it, really. The point is, this is called dependency inversion principle. It seems easy, but it's not that easy, really. The point is to have abstractions, higher level stuff, independent on lower level code. So then, there you go. If you do that, what do you gain? Nothing from the lower level module can ever enter the domain, right? It's kept out of your world. Nothing. Data structures from outside. Nothing. Uncle Bob even calls this the best thing OOP gave us. I hope I'm not doing a mistake. I saw this somewhere. But then you can do this wherever you want to start an interaction with the 4 possible integration paradigms out there. Synchronous call, asynchronous messaging, file transfer, or DB links. Whenever you, from the domain, want to initiate a communication using an integration using these paradigms, you can put the data structures of them out, right? That's the point. Now, It allows you, in the end, to focus on your domain logic, not on other APIs that you have to consume, right? You can focus on what you have to do. That's the main goal, main benefit of this thing. Good. So again, let's put it all together. We have interfaces that we lay out in the domain and we implement outside. So we have in front of the user the application, then we apply dependency inversion, we extract the infra, we extract the repo, and perhaps some application will extract a batch. Now, notice the direction of the dependencies. They all depend on Rome. There was a quote. All roads lead to Rome. You know?
It says, omnis via Romam ducunt.
That's it. Great. Thank you. Thank you. So I couldn't have said better. What can I say? The point of this stuff is that this is, my friends, the onion architecture in which the middle of the onion is sweeter than the outside. Did you know that? When you cut the onion, you cry because of the exterior. This interior is sweet. Good. They reinvent this architecture every 5 or 7 years. It was named hexagonal, ports and adapters, many names, the same stuff. Good. Now, you have enemies in front of you, enemies behind you, and sometimes enemies underneath you. I get it, huh? And then, what do? I'm a pragmatic guy, so what do? I merge things together. I name it domain, I name it application. The dependency is the same, but I just gathered all the garbage together. 2 Maven modules are enough for more. I call it the pragmatic onion. A pragmatic onion. So basically, for decent applications, not more humongous things, 2 are enough. So I have applications older than 3 years, which are still very fine with this approach. We thought of breaking it into pieces, but we found out we didn't gain anything, really. Okay, naming. Let's forget about the architect. Naming. Package names. Sorry. Come my org, my app. And then you start. You say service entity infra repo. Util. I forgot the util. I should. Util. Yes, we saw yesterday. Yes, util. Good, but then they grow up, and when they grow up, what do? They are very large. So what you want to do? You want to break them into sub-packages. So you split it in product and order, of course. Several months, several weeks after, you think, oh, wait a second, the entities are also very, very many. So what do? Order and product. You feel it? Are you there yet? And then the repo splits, naturally. And the facade also splits. So where do you end up with, really? Now, you end up in a place in which you have a first level of separation by the logical layer name, and then a second level of separation by the domain area. So what could you do? Think. Switch, of course, what the heck? Switch, crack it, and name it the other way around. Uncle names it the clean architecture, basically, in which the first level of package names reflects the domain knowledge of the application, not some opaque layering, right? Very interesting, and let's do that. And so then we have 2 onions. 2 little. Do you know that when they plant onions, they don't literally plant seeds? There is a little kind of onion, very small, which gets planted. How do you call that? Anyway, in Romanian it's arpaggic. Anyway. So you have 2 such little onions in the single code base, in a single Git. And now we will start the journey. The journey in which many of my clients are, for many, many, many years already, to decompose the monolith. Who does that right now in your projects? To crack a monolith. Oh, so not that much, 10%. So you have to split it, and you want to isolate order from product. So what do? By the way, I strongly recommend to check out the Axel Fontaine's talk on the majestic monolith. It provides a set of stages towards distributing. You can stop at any stage you want. You don't need to go to micro. You can stop. That's the beautiful part. Just look, it's very, 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 very good. So then, the first question, should a service, should an entity from one domain depend on one from the other? Well, no. So what do? You stick in the idea of the other one, right? Then, should the domain service call directly the middle of the other onion? Not quite right, because you still hope for micro. And not even that, you want to isolate the core logic from one another. So what do? You ever seen a monkey scratching like that? That's the, whoa, you're calling through the, take the long path, right? And you put a DTO, this is interesting. This might become tomorrow a JSON over wire. Okay, then transactions are the next stage, and this causes panic for many teams. Panic for many teams. Why? Because you start playing with something very critical, the consistency of your application. Whenever you want to kill the transactions, you will sacrifice consistency. And this is a place in which many teams have to take a decision. It's interesting how to fix it. Spring actually offers an interesting way of doing that technically by events dispatched from one area to the other. But the point is to have separate transaction. Even if for a single use case you have to touch 2 little onions, you will start 2 transactions. But this, of course, leads you to inconsistencies. That kind of stuff when the user just created the customer, searches for it and doesn't find it, and submits a bug. And what do? The customer will appear there in 1 second. What do you do to the Jira ticket? Cannot reproduce. I've seen people take horrible shortcuts. They were actually faking a row in the table. Then you like to separate the 2 databases, right? And that's another pain point because you need to sacrifice reference integrity, which is very painful, very, very painful. Yeah, I think even more painful than transactionality. So at that point, you say, whoa. Ideally, there should be schemas with no links between them. And you will start replicating data. You will start suffering. In the end, this is also light CQRS over there. Queries can span different areas of the database because they will eventually end up being some, elastic something. I don't know. Maybe, right? So feel free to select both places, but not foreign keys. Very, very, okay. And in the end, there could be the micro. That's a book which is pre-published. It's not even on paper. Sam Newman just tweeted several days ago that he had this on, and I found it on O'Reilly. I would recommend having a look at this. Interesting. I'm still reading it. Sounds interesting until now. One other thing you can do. Have you ever heard of ArchUnit? ArchUnit is a framework, not mine, for Christ's sake, no, it's open source, that just can put rules, boundaries. Look how this reads. The classes in the package service should only be accessed by the controller or service, or facade, not from the repository. If that's the case, the build will crash. That's a JUnit. And Jenkins will serve you. Okay, so remember again, it's your garden, it's your code. No one else will care on where you live. It's your job to make it clean. Who knows what this is? What's that? An animal very, very small, microscopic, you can see that. It's called the water bear. It can resist in outer space for 5 minutes. It can almost resist an atomic bomb falling on it. It's the most resilient organism on the planet. You can find it in every muddy puddle. Everywhere. It's there everywhere. It's called tardigrade. But the point is, scientists are asking, how the heck did that evolve that way? My point about that is evolution only happened under constraints. And I don't want to think about the constraints that this fellow suffered, right? So this leads us naturally to the fitness function. Do you recall the how is it called? Evolutionary architect, the evolutionary program. No, how is it called? With the populations that with the clustering algorithms, you had the fitness function in computer science. Do they studies? You have a fitness function that you can enforce there to keep your project on track, right? Being computed automatically every time you commit something and showing you a grade, not the sonar grade. No, another one that you customize yourself. Books, lots of books this time, many books this time. Key points, core principles. The main principle I would like you to take from this, keep it simple, folks. Avoid over-engineering, keep the things as simple as possible. Employ little magic to help your developers. Take steps beforehand to avoid disasters, but don't overdo it either. Modeling. Realize there is enemy data out there that you want to defend yourselves against. And logic. Try this approach once. Try to extract when something grows. Let it grow a bit and then extract. And the onion architecture is all about the dependency inversion principle. Let your domain be agnostic to anything external of it. And tests. Here, we didn't talk about that. There will be a talk after lunch, here again. Let them smash your design. This is Sparta, right? Test will give you feedback about your design. And in one word, keep it simple. What's next for you? The fastest way to learn is to teach the others. The fastest way to grow into a senior is to help the others grow. That started me, really. And anyway, another thing I want to take out of this, put passion in all that you do. It's your life, folks. Do it with the best you can. One last thing. Please hunt me down for questions. I'll stay here. Ask. Thank you. One bad news, I don't have stickers. They took them all yesterday. All of them. But you can download some printable versions from Victor. You can even edit them. There's a PowerPoint. You export a JPEG and print it. That's it. Thank you, and see you soon of 1 hour.